You know, humanity just invented a computer chip that can literally survive the absolute hellscape of Venus. Like, we've basically mastered the temperature of lava.
It is incredibly dramatic.
Yeah.
I mean, it really blurs the line between science fiction and just, routine engineering.
It really does. Welcome to Casutalks, everyone. Grab your coffee because today's deep dive is just wild. We are looking at USC research, ESA missions, and the new Cygnus XL launch.
A very heavy stack of sources today.
Oh, absolutely. And our mission today is to figure out how pushing our technology into these brutal, extreme environments in the solar system is completely rewriting the rules of what's possible back here on Earth.
And we really have to start with that Venus-level heat. It is just staggering.
Right. So a team at USC just created this nanoscale memory device, a memristor, and it runs flawlessly at 700 degrees Celsius.
Which is hotter than the surface of Venus.
Exactly. Venus usually melts our probes into slag within like a matter of hours.
But what stands out to me in the USC paper is, 700 degrees wasn't even the point where the chip failed.
Right, really?
Yeah, that was just the maximum limit of the scientists' testing equipment. The device itself showed zero signs of degradation.
Oh my gosh, that's insane. Okay, let's unpack how they actually pulled this off, because the design is basically a microscopic sandwich.
It's a very, very hot sandwich.
Right. The outer layers are tungsten, the filling is a ceramic called hafnium oxide, but the real magic is the bottom layer, which is graphene.
Exactly. Normally, at those extreme temperatures, the tungsten atoms drift due to the heat and cause a fatal short circuit.
But the graphene layer acts like, a futuristic non-stick frying pan.
A non-stick pan, yes.
The drifting tungsten atoms get all agitated by the heat and try to bond to something, but they just slide right off the graphene. They literally can't find an anchor. And no anchor means no short circuit.
That is a brilliant way to visualize it. And if we connect this to the bigger picture, mastering extreme heat at the micro level gives us incredible macro level access.
Meaning what, exactly?
If our computers no longer melt, we can finally send them closer to study the ultimate heat source in our solar system, the sun.
But to actually send a physical technology that close without it getting destroyed, we have to understand the chaotic environment surrounding the sun first, which is exactly what the European Space Agency's Proba 3 mission is doing.
Proba 3 is a fascinating feat of engineering. They are flying two satellites in a highly precise formation.
Like an orbital dance.
Basically, yes. One blocks the direct sunlight, acting as an artificial moon, while the other trails behind and just films the sun's corona for hours on end.
Which is huge because we used to rely on total solar eclipses here on Earth to see the corona, and those only last a few minutes.
Right, and their first batch of data is already challenging our assumptions.
Yeah.
They found that the so-called slow solar wind actually travels at 250 to 500 kilometers per second close to the sun.
Okay, here's where I have to push back.
Oh, here we go.
If this wind is blasting at 500 kilometers a second, why on earth do astronomers insist on calling it the slow wind?
It is incredibly counterintuitive. They call it slow simply because the fast solar wind travels at around 800 kilometers per second.
Okay, show-offs.
But the real mystery Proba 3 is solving is why it moves that fast in the first place. The slow wind accelerates rapidly close to the sun due to these highly complex, tangled magnetic fields in the corona.
So why should you, the listener, care about magnetic winds millions of miles away?
Because that wind eventually hits Earth. These solar winds trigger geomagnetic storms
Which can wipe out GPS networks, right?
and even overload the terrestrial power grids we rely on every single day. Understanding this space weather is critical for protecting our infrastructure.
And it is also critical for protecting the massive logistical supply chains we're currently building in low Earth orbit. I'm looking at the manifest for the recent Cygnus XL launch.
Oh, a phenomenal launch.
It went up on a Falcon 9 rocket carrying 11,000 pounds of payload straight to the International Space Station. I mean, did they pack enough casual space snacks alongside all that?
I certainly hope so. That is a staggering amount of mass. The SS Stephen R. Nagel, as this craft is named, is carrying some heavily experimental cargo.
Yeah, specifically a brand new quantum science module and hardware designed to produce therapeutic stem cells.
Right.
Okay, but why send stem cell research and quantum computers all the way to space? What does the ISS have that we don't have in a lab down here?
It comes down to gravity. Down here on Earth, gravity flattens stem cells in a petri dish,
Yeah.
which alters how they develop.
Oh, interesting.
But in the microgravity of the ISS, those cells can grow perfectly in 3 dimensions, mimicking how they actually formed in the human body.
Oh, wow. So that leads to vastly superior therapeutic treatments.
Exactly.
That makes total sense. And for the quantum science module.
Well, quantum qubits are incredibly sensitive to environmental noise. The extreme cold and vacuum of space offer a unique environment to test cooling and isolation methods that are, incredibly difficult to maintain on Earth.
Which could radically accelerate our quantum computing capabilities and even aid in detecting dark matter.
It is wild to think that surviving the vacuum of space is now just a prerequisite for next-generation medicine and computing.
It really is. Well, that wraps up our deep dive for today.
If you enjoyed the conversation, please like, share, and maybe drop a comment with your favorite moment from today.
Yeah, comment a funny phrase from the episode. Something like non-stick Venus or speedy slow wind.
Non-stick Venus is a strong contender.
Absolutely. We'll be back tomorrow with another deep dive into the ideas shaping our world, so definitely come back for more Casutalks.
Until then, I want to leave you with this thought. If we now have computer chips that can literally operate while submerged in lava, what other supposedly impossible environments in our solar system are about to become our new backyard?